Good day to you. Thank you for visiting my virtual poster on use of neuromodulatory ultrasound to treat multiple sclerosis and dementia. My name is Mourad. I'm at the University of Washington, affiliated jointly with the Departments of Neurological Surgery and the Division of Engineering and Mathematics. This work has received funding from FUSIF, from NIH, and from the Department of Defense. What I'll discuss very briefly is animal-based work suggesting that ultrasound that activates the brain can in turn activate other cells within the brain in a way that has the chance to therapeutically treat multiple sclerosis on the one hand and Alzheimer's disease on the other. First, I'll turn to multiple sclerosis. I was motivated by work that came out around 2014, where people showed that optogenetic activation of neurons in transgenic mice who don't have multiple sclerosis actually have myelin sheaths that thicken thanks to this optogenetic stimulation with a very specific light pattern in time. And I thought I could do that with ultrasound. And that might find value for treating multiple sclerosis, which is a disease of the myelin sheath in the brain, whereby the myelin sheath decays. It occurred to me if I applied ultrasound with the same temporal pattern as the optogenetics team, and if we activated brain with that temporal pattern, that perhaps we could decelerate demyelination or accelerate remyelination. As it turns out, what we discovered is that we can accelerate remyelination. In particular, we published a paper a couple years later. I did so with colleagues from neurosurgery, showing exactly that. Specifically, we applied ultrasound in the rather complex temporal pattern that you see here. It's 20 pulses per second, applied for 30 seconds with 90 seconds off, and done so for 30 minutes, done 5 times a day. And we asked if mice experiencing remyelination could get more myelin where we applied ultrasound. Here are 2 examples. The left-hand column shows the myelin stain. We applied ultrasound into the corpus callosum, and from your perspective, the left-hand side of the mouse brain, the myelin stain is darker where there's more myelin. In this case, where we applied ultrasound, has more myelin. The right-hand column shows 2 corresponding examples that show with crescent violet staining that we did not disturb the neurons. And when you aggregate across all our animals, in this case 7 of them, we saw a statistically significant increase in myelin where we applied ultrasound compared to the contralateral side. This is about a 15-20% increase in myelin over a period of a week. Very encouraging results. Next step would be to apply this to an autoimmune mouse model of multiple sclerosis and then consider it for human application, because these ultrasound protocols aren't that far from diagnostic. Next, we considered ultrasound of a different sort that still activated brain for addressing dementia, motivated by a paper that showed if you flash light at 40 hertz in the eyes of mice that have a buildup of amyloid beta in their brains, that light pulsed at 40 hertz will in turn activate the microglia. That will in turn munch up about 50% of the amyloid beta, but only in the visual cortex. My team and I decided to try this in a larger portion of brain. Specifically, we developed an ultrasound protocol that activated brain 40 times a second and discovered that we indeed activated microglia and hoovered up about 50% of the amyloid beta where we applied the ultrasound. So we published this work in brain stimulation a couple years ago. And if you follow here in upper left-hand panel, there's our device aimed down below into one, in this case, or 2 hemispheres of mouse brain. And these mice are transgenic mice and have an excess of amyloid beta. When you do so, lower right-hand corner, acutely, 1 hour, you get an activation of microglia here shown by the hotspot in the figure. If you do so every day for a week into each hemisphere, you get a reduction in amyloid beta where we applied the ultrasound by about 50%. I've given you two examples there, sorry, one and here are some more. On average, we cleared almost 50% of amyloid beta plaque um, as compared to sham-treated animals. Very encouraging results, and we're considering human trials for this protocol because it's so close to FDA-approved ultrasound. So to summarize, uh, the work I presented here of my colleagues and I suggests that it's possible one day that ultrasound that activates the brain can in turn activate oligodendrocytes in the case of multiple sclerosis, or microglia in the case of Alzheimer's disease, in a way that can produce a therapeutic effect. For multiple sclerosis, we seem to increase the amount of myelin, hence the amount of oligodendrocytes wrapped around axons. In the case of amyloid beta, we have activated microglia in a way that caused them to reduce the amount of amyloid beta in brain. Thank you very much for your time.